Solve x sub m equals x sub 1 plus x sub 2 all over 2 for x sub 1. This is our first example of a formula that has variables with subscripts. Those little numbers written below and to the right of a variable, these are subscripts. Now, in this problem, there are 3 different variables that have x, but each one has a different subscript, and so those represent 3 different variables. We could have written these as x, y, and z, but it's sometimes more appropriate to use variables with subscripts so that the letter that we use has meaning. The letter m here means mean or average. If we want to know the average of 2 x values, we take the first x value, x sub 1, and we add it to the second value, x sub 2, and we divide them by 2. You may have seen something like this before. The average of 2 numbers is their sum divided by 2. If we were taking the average of 6 numbers, it would be the sum of all 6 numbers divided by 6. But this formula in particular gives us the mean or the average of 2 different x values, which is why we use x in each of these. If you haven't already seen variables with subscripts, you will probably see them fairly soon when calculating slope. The formula for slope involves variables with subscripts. Anyways, our goal is to get x sub 1 alone, and to do that, we need to get rid of this fraction, and the denominator here is 2, so we need to multiply both sides by 2. And there's 2 ways that we can do this. First, we could just multiply both sides by 2, and then notice on the right that the 2's cancel because the denominator is 2 and then the outside is 2. So that gives us x sub 1 plus x sub 2 on the right and 2x sub m on the left. There is another way to do this, and I'm actually going to wait until the end. Let's finish this way first and get an answer, and then we can look at the other method. Now, our goal is to get the x1 or x sub 1 alone, so we need to get rid of this other term, and we can do that by subtracting x2 from both sides. On the left, this gives us x1 by itself because the x2's cancel. And then on the left, these are not like terms because these variables have different subscripts, so that makes them different variables. So we're just going to have 2x sub m minus x sub 2, and this is our final answer. Now, sometimes students struggle with dealing with fractions that have more than one term in the numerator, and so there is a way that we can sometimes make it a little bit simpler, and we can take that and split it up into 2 fractions. So we could take the x sub 1 plus x sub 2 over 2, and we could write it as x sub 1 over 2 plus x sub 2 over 2. It's another way of dealing with this. We still need to multiply both sides by 2, but now on the right-hand side, we're going to have to distribute. So on the right, when we distribute in the first term, the 2's cancel because there's one in the bottom and one out front, leaving us with just x sub 1. And then also when we distribute to the x sub 2 term, the 2's cancel as well, leaving us with x sub 2. And then on the left, we have 2x sub m. And this is exactly what we had just a minute ago. We know that we can finish by subtracting x sub 2 or x2 from both sides. And that gives us 2xm minus x2 equals x1. Why do we spend time looking at these 2 different ways of doing the problem? Well, because sometimes students make mistakes when they do things the first way. In the first way, we're able to cancel out these 2's because there's a 2 effectively in the numerator. You could think of this as 2 over 1, and then a 2 in the denominator. We're effectively cross-canceling the 2's. There are some students who want to cancel out the 2's, but then they also want to distribute the 2. And we can't do both of those in the same problem, because if we're going to distribute that 2, it doesn't end up canceling with the denominator, at least not in the same step. It cancels later. So you really have to make a choice here. If you're going to just do the multiplication without distributing, you can cancel in the top and bottom. But if you're going to distribute, you have to go through that distribution, and then in each term, you can cancel it. But you can't really cancel first and then distribute, because after you've canceled, there's nothing to distribute. Maybe this isn't a big deal for most of you, and I'm just going on, but I have definitely seen students make mistakes with situations like these, so I just wanted to take a chance and show you the different ways of doing it. Specifically, the piece of advice I have is to make sure that you're showing your work clearly and consistently, because if you do that, you're less likely to make mistakes.